Let me introduce the area. This is a satellite image. This is the Rio de la Plata. This is the Paraná Delta. Here is the Buenos Aires city. And it is from north to the south. In the opposite way maps are currently. But we are southern. As South Africa, Argentina, Chile, we are, well, that is the name of our project. It is quite long, so we call it the Rivera project. Rivera mid-bank shores, something like that. But that is our logo, and we are strongly supported by IDRC, and that is to say, and that is the Argentinian-based institution for research and studies for development in Latin America. And in the Uruguayan side, you have the strength of the wind, because most of us are meteorologists. And I shall present you some hydrological and climatic analysis selection of topics for this conference. Well, let me put the map in the common side. So, this is south, this is Antarctica is beneath, and the equator we are up. Alright, again, this is the area. Let me focus. And here there is the rain gauge we study and the towns. But Tigre, it is one of the towns involved in the project, hasn't any rain gauge. That could be put in red. Well, the institution will start in this year. Oh, please. This is the Argentinian institution. Here we are, and the funding. The duration is 36 months. The coordinator is present here, is Florencia, and me is the presenter. That is the main objective of we have some brochures in case in English and in Spanish. And the specific objective is to identify, analyze together with local stakeholders, that's the problem, the climatic, hydrological and atmospheric challenge in the research area tested. To analyze the perception of the local stakeholders, and to help to design guidelines together with local authorities and social organizations. And from South Africa is some problems they put into the table. But there's different communities, the local governance and the really people. It was already stated. And to disseminate results, not just for international journal, but also for local and regional meetings. And that's it, when I put the focus in the presentation. Well, here is the 4 towns. This is Guanacaste and Carmelo in Uruguay, and Tigre and San Fernando in Argentina. That 2 towns belong to the neighborhoods of the big city of Buenos Aires. And they are more isolated. And also, we have a ruler to handle the tides in Buenos Aires, and there's an AF, that means in English WF. The hydrological issues with a consultant, and me for the climatological issues. And the 3 is the huge flood induced by large river overflow, that is the Paraná discharge and the Uruguay discharge into the Rio de la Plata. The floods provoked by local heavy rain, and the sudestadas on other regional wind stacking water on the banks. Well, and that for the dissemination population, this kind of information is already easily retrievable for internet, and local governments don't need any help for our project, for any of the 4 towns involved on our project, that we did not need to put a focus on that. But when you find some difference that we pick with the local data among the high rivershed, the medium rivershed, and the low rivershed of the small creek traversing the town, this kind of data probably exists at technical levels in central government agencies, but is lacking locally. And that's, I guess, why. And maybe one of the tasks of our project and your projects is to put it on comprehensive ways into the local governance. The same for geomorphological features that lacking locally, but maybe existing at technical levels and government agencies. And on the other way, the classical climatic data or the presentation is lacking of interest and lacking of practical application. We don't need to insist to this in our participation action project. But so we try to put the data in a different way. For instance, how events from some the period of return of heavy rains in each locality may be more interesting to local people because they improve the perception. That this new information is used for local data and processed at the project, and is used to redesign stormwater and sewage system, and could also change perception on risk in citizenship. So we have to translate the data available in something that could impact people. Here's another way. For instance, let me take the example here in San Fernando. Each 2 years, we can hope to have 100 millimeters per day precipitation. Certainly, it will make a flood in the town. But the historic, we willingly, that is nonsense to construct new urbanization without taking into account of that. But what is the distance among the historical maximum? That is more than 15 years of return. So, but you can see that the local maximum historically reached a little 50% of the iconic 100 millimeters per day, and that could be useful to help in the guidelines to stormwater and sewage system and new urbanization. Well, let's see the other part, that is the flood by the wind. That is the annual number of days in high water levels, and that means the exceeding 95 and 98% percentage ranks. How many days per year? And we can show an increasing in the Argentinian shore of the number of days flooding by the wind. But in the other part, we look at the opposite. And what is that? Maybe parallel to the project, we are studying the trends of the wind, regional winds, and we found a shift in the wind regime. But the question is, the wind regime is the steady data, is the median or the mean of in the direction. But the surge here is transient. It's just a few days. So maybe it could be some bug in measurement methods. But the institution, the government, are reluctant to they complain, no, the data is good. We are in a fight trying to better understand this kind of trend. And that is a long process. Well, also, we have the long-term driving, that is the high, sea level rise, that is in Montevideo, like in most part of the world is rising, and is rising, the more is rising in all the American continent. It's just in the offshore, the Rio de la Plata, so we have local data and satellite data match very well. And what it means? Well, the old IPCC models told about 4 to 8 centimeters by 2020. That is the centimeters high. But how much is the invading area in the coast? From 10 to 100, the height. It depends on the slope. But this information is in any way affordable for any local governance. I don't know. Not yet, at least in the 4 towns in our project. But this is the old data. Renato told us about the new. The new data accounts for 40% huge in all these scenarios. Well, the Sud-Est Atlas is the local name for surge driven by the wind. That is the anticyclone in southern hemisphere, and in some location with steady winds put the ocean waters into the Rio de la Plata. There is a trend among the decades increasing in frequency, and in the case of the Argentinian bank, where most of the investing is situated for all the Argentinian country. There are a lot of studies, a lot of literature, and we can find the distribution around the year, and we can split with or without precipitation. It could, this is in one period experimental. We took in this research, and it is the pattern of the flow, that is the current of the wind, put in the area in 63 days. That is the local indicator in Buenos Aires who can tell us that is a really Sud-Est Atlas, it is a high level. The forecasting service for this kind of event is already in place for the Argentinian bank. Not sufficiently spread in the population, but it works quite well. but it is inexistent in Uruguay. Well, we can put the forecast for the Argentinian service. No problem, communication is quite good. But there is another box. In the case of Carmelo City, they fit the big sudestadas in Uruguay, in the Argentinian band, fit with the 17 cases in this period in Caffera. But in Juan Lacase, it could be that is the mean of all the situation, providing enough wind to put the waters in, and locally suffering in Juan Lacase. But there is differentiated sudestadas from both bands. This kind of situation with a strong, low pressure here, with southerly winds, there is no sudestada at all in the Argentinian bank, but a very high tide in Juan Lacase. So we need to split and to analyze other patterns for this experimental town in our case, because of the southern wind. The pattern, the mean of this kind are different in shape that in the Argentinian common traditional sudestadas. And we can find that from all the 22 cases in this period, in Buenos Aires, we have 29 cases in Juan Lacase. And from this case, only 16 are coincidence with Buenos Aires. The remaining case remain to assess, and we are doing that. And that is some too much meteorological, sorry, but when gross shore flooded, we have strong winds in altitude in the atmosphere, down in the south of us, in the Patagonia, and almost no strong winds in the north. That is in 11 kilometer altitude when your planes came that altitude. And in the only Uruguayan shore, the highest wind arrives northward the Rio de la Plata. 2 days before, you have this kind of difference. And that could be useful in order to make a new warning, early warning system in this part. That is the -1 of the record of the highest tide, and the wave and the wind, the upper level winds, are less pronunciated in the only Uruguayan shore at high tides than in both sides. So, and that is exaggerating in the same day of the storm surge. That is 11 kilometers high in the atmosphere. Very different. High winds, strong northward, and here a huge wave in the wind. And that could be a difference. Well, we have shown some findings on climatic and water issues in both bands, some difference and similarities that will be able to provide differentiated early warning. Not the same occur in each one of the towns, and it needs different kind of patterns. Our current and next activities are complemented study of flood peaks aided by growing large rivers and local rainfall or wind stacking. the rowing, the floods, the high levels of discharge in both high rivers is a complement that could be more huge in the case with local rains or wind-driven high tides occur. In these towns, just high discharge for big rivers don't means necessarily flood. We continue study of possible change in frequency and intensity of flood peaks in each one of the 4 towns, and we are trying to determine the frequencies of this condition causing water stacking in each location and possible change of frequency by downscaling global climatic model into the future. That is, we are using the Huddle-centered climate dynamic model because it's one who fits the most in this area with climatology. There are the bugs. I will not insist with a lack of data in our institute. It is boring, everybody knows. But we spent almost 1 year in procuring the data used for the global climatic model. That is an issue when you have, in terms of the deadlines in the project. Some of the data of some of GCM remain not out by foreigners. Because those belongs, that is the lack of data institution. But the big issues, technical issues, belong to 2 very intricate categories. The slow or the speed change in the case of sea level rise. Well, everybody would, the actual shore is here and in the next 20 years will be there. It's almost clumsy, but it's almost all we can do with this slow speed change. We are not certain that it will happen really like that. The other is the transient characteristic of a storm surge and windy weather that puts a challenge in utilizing global climate models and so on. We shall explain that in the order in the next panel. But both are not easy to assess when working with GCMs. But it's the only way to look forward. Well, that is.